Okay, everyone, welcome. Thanks for coming. It's a really, really good attendance for the first week. Every week at 12:35, for those of you who aren't familiar, we have either a professor or a member of the local weather community, weather service, or AccuWeather or alums come and do a 20, 25-minute weather discussion. Hopefully this is interactive, informative. Feel free to ask questions, especially at the end. And we're happy to have Rich Grumm here. Rich normally does our first and last briefing of the semester. He's at the Weather Service here at State College. Thanks, Rich.
Thanks, Ryan. So not a lot going on in the world today. So you can see we had a little fog this morning, and then of course we're just kind of a self-destruct stratosphere, cyclonic aloft, and we have a cold air mass of a lot of us. It's slightly below normal. It should get up to about 5,500 hectopascals. So nice self-destruct too, but pretty quiet weather pattern. Oh, I forgot this. It's like hurricane trying to get going with Erica with a K, and then that's probably like the most exciting thing in the forecast for a lot of people, I guess. But we'll get to that, I think. I want to do kind of an overview of just of some forecasting ideas, because a lot of people may be new to this, and it's been some people, we haven't done this since May, so I took kind of a overview flavor of what we're going to talk about here. During the course of the semester, hopefully a lot of people will present ensemble forecast system information to you, and a couple of the global ensemble forecast systems you might see this semester might include the NCEP Global Ensemble Forecast, GEFS, the North American Ensemble Forecast System of the NAEFS, and then the Short Range Ensemble Forecast System of the SREF. I just got an email today. They're just releasing a parallel version of the GEFS. It's going to be run at 33 instead of 55 kilometers. So I'm going to try to get that feed going, because it's nice to see if it has any differences with the outcome of Erica. I just got the email before I came over here. Of course, there are other ensemble forecast systems and other like the EC and the UK and the CMC. And the NAEFS actually contains the CMC, the Canadian Meteorological Center's ensembles. And when you're forecasting beyond about 2 or 3 days, it's probably best to, you're going to use a global model, you probably should be using an ensemble. And then we'll talk a little about the 3-kilometer high-resolution rapid refresh model with a HER. It's good for short-term weather issues, and hopefully, I don't know, anybody here like a freshman or a sophomore in the audience, hopefully by the time you graduate, that will have like at least some kind of high-resolution ensemble forecast system to help us deal with the uncertainties of weather forecasting. And then there's this hurricane note we might get around to talking about. So the systems we use and why we should use them, and over the semester you'll see a lot of them. You know, for the longer range weather, you'll see a lot of people use global models or GMs, and they'll talk about ensembles, and I'll use EFS as a short-term an acronym. I work for the government. We take a class in acronyms when we get our jobs. And so they're good for the large-scale pattern and potential synoptic systems. The more used ones, like I said, are the GFS, the EC, the CMC, and the UK Met. There are a lot more, actually. The Australians, the Japanese, the Koreans. A lot of people run global models. CP Tech in Brazil. They have the deterministic run, they have a control run, and then they have the ensemble forecast system. And the longer out in time you forecast, the more likely you should be using one of these anyway to deal with the uncertainty issues, because they really provide us a better insight into the uncertainty, which we'll look at briefly as an example coming up here. Then we have the high-resolution regional and models and ensembles, the SREF, the NAM, it's run at 12 and 4 kilometers, the RAP, and then the HER. And I believe you're going to have guest speakers here in October from 2 Penn State graduates who are developers of the HER. I guess it'll be in October. I think Curtis and maybe Stan Benjamin, I believe. So it's probably a worthwhile talk for people who like short-term weather forecasting. And these rapid refresh models have great potential, and the ensembles that are slowly evolving out of them really are going to change how we forecast the weather in the short ranges. So here's an example of this happens to actually be the European Center's 52-member ensemble from yesterday. It's the 26th. And the really bright yellow line is the mean. It's the high resolution in the control of the ensemble. But you can see the forecast of this cyclone that was supposed to come yesterday right over Florida. But you can see as we went out in time, the track of the storm diverged. And then today, the models kind of changed the forecast of the track of the storm. They shifted it probably a subtle 100 kilometers to the east. So you can see just in one day, it was a pretty big change in the forecast. And now it's going to do this like a loop-de-loop off the East Coast, at least the EC ensembles. So the one thing about ensembles, they help us see the range of solutions so we don't get all excited and overhype the fact that Florida is going to be experiencing death and destruction on the 1st and 2nd of September. Of course, now the storm's even faster. We have two issues. Well, we have multiple issues with the storm. We have the track of the storm, we have the intensity of the storm, and then we have the timing of the storm. And they're all changing. So when you're forecasting longer range, you have to be a little aware of the limitations. So these are this is the NCEP GFS, and then next to it we have the NCEP Global Ensemble Forecast System. And these are the forecasts showing the high resolution model here where the cyclone is supposed to be based on the 0Z run. I didn't use the 6Z run. And then this is the ensemble position. You can see with a large spread. So you can see there's a lot of uncertainty. But currently the NCEP GFS and its ensemble twin are kind of saying the storm's probably going to go up the east coast of Florida or stay just offshore, which is kind of in line now with the EC ensemble forecast system from this evening and this morning rather and yesterday. But you can see the single model, since it only has one model, it really shows how deep potential of this cyclone is, about 6 to 7 standard deviation below normal cyclone off the Florida coast. And you can see it has a potential to produce a lot of rain, and everybody knows Florida's in a drought, so this hurricane is clearly not a dry subject to them. So anyway, but this is the forecast from yesterday, about the same time, and then GFS had the storm going up the Florida Peninsula. So when we make long-range forecasts, we have to be cognizant that these forecasts will change. And there's differences and subtleties in the timing, too, but let alone the intensity of the cyclone. Oops, went the wrong way, my bad. So anyway, so we have to always be mindful, especially that prediction is very difficult, especially about the future. So all forecasts really should be taken from the approach of what may happen, not will happen. We tend to be over specific about what's going to happen, especially when we're trying to sell 24-hour news and weather. So our forecasts are always inexact. So yesterday we were hearing all the doom and gloom for Florida. There's a little less doom, a little less gloom, but there's optimistic hope for some rain. I'm actually hoping the storm at least gets close to Florida. I want to see how the 3-kilometer hurd does with the rain bands that could potentially get at least close to Florida. And the hurd actually covers out to some of the islands, so maybe we'll see how the hurd does hurricane rain bands. But it's interesting to see. But the probability of Florida getting struck by this potentially large storm is changing on a daily basis. It'll change again. I think the last run I saw of the GFS, it kind of wobbled it a little to the west again. So we also have to be mindful of tempering our forecasts because they will change. When it comes to regional weather, locally here, because the hurricane it shouldn't affect us much other than probably strengthen the ridge that's going to be over our area most of the time over the next week and a half. But the GFS and the combined GFS CMC of the NACE, we'll look at the pattern from that, and then we'll look a little about the short range hurd. So here's the mid-weekend forecast from the large-scale 52-member ensemble. You can see we're kind of in this weakening trough. There's a building ridge out ahead of our little special storm, and there's the weakness in the ridge down there. You can see the warmest. These are anomalies, departures of the ensemble mean from climate. See, the really warm air in North America is kind of focused over the northern plains into Canada. There's a little bit of a warm anomaly with the tropical storm, and there's a weak little trough through the midsection of the United States. I don't know if you've been watching, but the precipitable water anomalies and the moisture variables, I guess, over the Gulf states the last couple of days have been really, really, really low. Like I think I saw the specific humidity was 6 standard deviations below normal in Louisiana yesterday. But if we go to the other side, you can see that there's not a lot of spread by the weekend. So we're pretty confident we're going to be stuck in this weak kind of ridge with some return flow over the ridge. We're clearly going to be moderating temperature-wise, which probably will help us increase our chance of actually seeing some more chances of showers. It's been a pretty dry pattern. But now, if we go to midweek, this is valid out Tuesday evening, and you can see the ridge kind of moves up over us. Maybe there's some hint of what the tropical storm is, and we finally get a warm anomaly over us. So, I actually wore those little arm things you put on your arm from the bicycle last night. I got cold, and I had a jacket strapped around my waist last 2 minutes because it actually felt chilly. It was in the 60s. When you go into 15 miles an hour, it kind of feels like a wind chill effect. But we have a chance, at least by midweek, to get above normal. And you can see there is some uncertainty coming into the forecast, but most of it's with the higher latitude features. And that pesky little thing off the East Coast. But it's fairly high confident forecast that we're looking at a potential at least warm up midweek next week, and so maybe when we get back in the 80s, and of course we get warmer, maybe it'll increase our chances of at least scattered showers. And so our short range weather, we've been under this big bubble, no trouble, but because we're cyclonic aloft, we've been getting strato queued out or getting the mid deck in every day. We've had areas of fog, and but if you look at the precipitable water forecast, this is valid tomorrow afternoon. We're still in a relatively dry air mass. There's a good plume of moisture setting up here with the approach of our tropical storm, and you can see this remnants of that really, really dry air over the Gulf states, where they probably had some really nice cool mornings relative to normal because of how dry it is. And you can see at the surface, we're just under weak high pressure tomorrow morning, so we'll probably have more areas of patchy fog around the area. I think the flow is going to get rid of this inversion we can get down there and the instability, so maybe we'll have less clouds tomorrow. I'm off tomorrow. I'm planning a big bike ride. I'm banking on it. So anyway, there's a chance of precipitation over the 24-hour period from tonight over the weekend. Actually, you can see even through Saturday, our chances of rain are really, really scant. And this ref this time of year has a wet bias because it's got a. That's my phone. I killed it. It's probably somebody trying to sell me some 800 number. I never get calls. It's only up in front of the group. But anyway, it looks like it should be a relatively dry start to our weekend. And I was saying the ref has a wet bias because it has to parameterize convection. So the weekend looks like generally pretty good weekend. I wouldn't be too excited about rain yet. And then and this just zooms in and shows like 5 to maybe 10, 1 or 2 ref members show any chance of any precipitation on Saturday over northwesternmost Pennsylvania. And again, it has a wet bias. So, and this is the HER forecast. There could be some sprinkles in the future in the northwest part of Pennsylvania, but in that really moist strip, you can see the HER. This is the synthetic radar, shows the potential. This is this evening of some rain off the coast, and it shows the showers and thunderstorm potential up in the plains. And if we look at the total precipitation that this particular run was putting out at 12 this morning, it's focusing some modest rain with the convection out there, a lot of rain out off the coast, with some potential sprinkles from the instability queue that the model generates. But I think that's probably way overdone. And then this just shows this afternoon that the model thinks that we're probably going to get into the 70s here, and a little bit cooler by the lakes. Clearly, temperature's still in the 60s. So, but clearly the HER has some potential things that could help us with a lot of short-term forecast problems, especially with colder dimming in the winter, stuff like that. So regionally, we've been in a relatively cool, dry pattern, and the forecast is tending towards a warm-up, and we might get our temperatures back up into the 80s. We haven't hit 90 here this year. So, I think the warmest I've seen in the NAFs is 18C. That's kind of pushing to get 90 here this time of year. But the shower potential increases, and I guess some of us could use some rain, but nothing great. It's just convective parameterization just triggering. And the GFS currently shows no big rainfall events for us in the coming week. So with that, I'm going to go switch gears here a little bit. We already saw what it looks like, what Erica looks like as it's coming through the Eastern Caribbean now. There's been some good footage. They've had some really intense rainfall, some nice footage of some flooding, which isn't good if you live there, but it was pretty interesting to see. So we will look quickly. This is the SREF forecast for our area for 2-meter temperatures. It's saying the median forecast says that we're probably not going to make 70 today. We didn't make 70 yesterday. But some members say we'll make 70. If it's sunny, the 2-meter temperatures this time of year tend to have a cold bias. But it looks like our temperature is probably going to be a few degrees either side of like 68, I guess. What's the temperature now out there? 67. And another cool morning, although we weren't as cool this morning as we probably thought we were going to be because we clouded up. And tomorrow looks just a tad warmer. We should get into at least the low 70s. Probably a better day to be outside. And then we can see the general trend for Saturday. And maybe Sunday the model might have some problems with it. I think it might rain or something because that was kind of odd. But it looks like we're going to get back into the 70s. And there's a little hint of a model saying we could actually get into the 80s, but that's clearly a huge outlier at this time. We'll check the quick look at the GEFS. I don't think 12Z is in yet. We'll stick to 6C. So you can see that general trend in the GEFS. There's a couple of oddball cool members, of course, but the mean and the median are pretty close, just showing this general trend. Like by the end of the weekend, early next week, we should have temperatures up in the 80s for a prolonged period of time, with really huge diurnal cycles indicating we're probably pretty dry. All our overnight lows are going to head back closer to the 60s and the low 50s. And surprisingly, the spread even at 850 and 7, it's not that bad. So probably have fairly good confidence in these forecasts. Little odds and ends with the lows and stuff, but it looks like a pretty consistent forecast. You're looking for precipitation. You can just see it's the diurnal convective if there's not really anything the model's focused on. So you can almost see it's all diurnal, driven by the CAPE in the model and the instability. So our weather looks pretty quiescent here. So if we'll switch back over to the GFS real fast, it's Control F11. It's a function F11. Yeah. F11. I might have did a function key. All right. So here we go. We'll cut right to the chase because we kind of nailed the weather here already. So this is the 12Z, the latest run of the NSTEP model, trying to see the track. It's got some hints of the low. It's bringing up so the 12Z run, unlike the 6Z run, actually has the storm on the 31st now, not the 2nd or the 1st, coming into southern Florida and going up right up the coast. And it looks like at this point in time, it looks like it's going right. I don't have a projection that has that zoomed in over Florida, but clearly there's been a trend in the new run. We'll see how the GEFS follows suit for the storm to actually track a little bit back to the west. So it's going to be one of those on again, off again kind of things. And if we go to the lower panel here, we can see that there's a huge potential for some pretty significant rainfall. Let's just go for grins. So it's hard to see, but this upper panel shows the 24-hour rainfall in the GEF. I have to change the contours on this image clearly. The 24-hour rainfall in the GFS relative to the 100-year 24-hour return period of rainfall. And it's hard to tell, but it looks like the contours are so tight it's hard to tell, but clearly it looks like there's at least a 75% to 100% chance they're going to have a 100-year rain event along the western. The rain in the GFS is going to be about 75 to 100% of the 100-year return pool. 24-hour rain. The beginning says that that's about 275 to 300 millimeters of rain. It's a 100-year event in that location. So anyway, these forecasts are going to keep changing. And I don't think the GEFS is in yet, but we can look. It's not in yet. So yeah, the latest GEFS I showed you in that one image was from 6Z. And actually, it turns out, I didn't realize this. We'll go. F11 doesn't even quite do it, does it? We got to go back to about, I guess, the 0Z on the first, maybe? The ensemble mean had the storm pretty much offshore with a lot of uncertainty. So if that worked like that, maybe we can go like this. Just for grins. I'm really bad with this mouse. We'll see if we can see. I might not go far enough south in Florida. It's really hard to tell. But it looks like I can see some greens and yellows in there vaguely, showing it's going to be a significant percentage of the 100-year return fall rain in Florida potentially from the storm, at least in this model run. So I hit F11 and get out of it, right? Anybody have any alibis we want to see, or are we just? So, we've already. I think we're all pretty clear with the local weather. From an Erica point of view, it's clearly the storm to watch and learn from because it's going to be a changing forecast. It's every ensemble forecast system, every run is going to show slightly different solutions. Clearly, the track has shifted to the east relative to yesterday, but now it looks like it's shifting back to the west. So it's one of those on again, off again things. I have a link here. You can look at the forecast tracks from the NSEP site. They generate tracks from the GFS, this Canadian model, and if you have the right email address, I guess, attached to your browser, I guess you can see the European center, which I actually showed. And so it'd be interesting to see when the 12Z comes in, where it has all the high QPF and how it tracks the storm. But clearly, it's a changeable situation, and it's probably the big thing to watch on the East Coast of the United States, and it's probably a good example on why we should be using ensembles in the forecast process. And here's the official NHC track that I got before I came here. It's the latest track. And they actually, if you've read the discussion, they trended their forecast of the system just to the west of all the ensemble guidance, because I guess the incipient cyclone that they found was to the west of the where it was initialized in the models. That was their justification. And then the GFS now seems to say, hey, that was a cool idea. Sometimes a blind squirrel finds a nut. So anyway, we covered some of the general forecast systems we're probably going to see and use over the course of this semester, and probably into the spring. We looked at our relatively quiescent weather pattern here over central Pennsylvania, and we looked at a little bit of Erica. You know, to miss or not to miss, that is the question. I'm not Shakespeare, but everyone's going to be watching this like a hawk. That's a paraphrase from the guy who runs the National Weather Service for many years ago. Any questions? Yes.
If you're an emergency manager in Florida, at what point would you start taking action or not taking action? Would you wait for the ensemble spread to become very certain? Would that be more on timetables of, let's say you need X number of hours in advance to make a decision?
That's an interesting question. I don't really know exactly how they behave, but from what I've read, and most people understand, they need about 72 hours to take action. Once you're inside 72 hours, you can't really do much. That's my understanding. So I guess right now you're probably ramping up for the worst case scenario organizationally, but what action you take, you probably have to wait. So once 72 hours from the tape, so probably within the next 36 hours, you're going to have to make a decision of some type.
For weekends, you don't want to all of a sudden tell everybody to do stuff on Sunday around. So you know how much time it takes. Then you add in just the realities of where you are in the work week, work day, and at some point you got to make a call. And you talk to the weather guys. The weather guys are going to tell you what they're going to tell you, and then you got to make a call. That's what they'll do.
So, anybody else? Yes.
I just want to make a plug. On the HFIP website here at Penn State, we actually track the hurricane. So it's the hfip.psu.edu. We run our WRF ensemble, and then it also shows the HWRF and the GFDL and then our ensemble members. And it incorporates airborne radar that's taken into our ensemble system. So it's something on a regional model to follow Erica online. It's really cool to watch, and it's been pretty good.
Sure, they just Google HWRF or HFIP?
Just type in hfip.psu.edu.
Oh, HFIP.
Yeah, so it's just want to put that out there. If you're wanting to follow something locally done here at Penn State, we run that, and it's done every 6 hours.
How far out the forecast go?
5 days.
5 days. It should capture it.
Yeah, it's been actually doing it. It's been doing pretty well, like keeping it pretty consistent.
They all should be wobbling because of initial.
Yeah.
Anybody else? Well, I guess that's it.
Yeah, there's one.
Oh, yes.
Yeah, if you could go back to the graphic with the probability of rainfall exceeding a certain.
In here, it was on the web.
I thought it was in here. Well, regardless, I can just ask the question. I noticed that the heaviest rainfall is predominantly on the east side of the track.
Oh, this isn't the track. Okay, we can switch.
Yeah, there it is. There.
Where did that load? Huh. Not loading anything. Do we lose the network? Okay. I have to click a button apparently. User error. The older I get, the more I do that. So here's like a GEFS forecast. Let me try a different projection. We need a Florida projection this weekend. There comes a tropical storm. Right about, is that a good place to stop?
Yeah, that's good right there. So it has the, it looks like the center of the low is actually right on the coast.
Mhm.
The precipitation is mostly on the east side of the track. I'm from the northeast, and both Hurricane Sandy and Irene both had predominantly more rain on the left side of the track. So I was just wondering, is there a simple explanation as to why this one has the precip on the east side?
There are some good papers written about the shear relative to tropical storms and where, how the shear is oriented, where the precipitation falls. Is anybody in the audience an expert on that? There are known different shear profiles that dictate modulating that.
Well, it could also
Sandy
be
was a-
interaction with the mid-latitude
Yes.
front
Yeah.
that is on the left side.
In general, with a storm like this, you know, so the people down there, they'll call the eastern side the dirty side of the storm. So you've got a couple things. You've got the rain, the track, and the dynamics all moving with there. So you're going to get more wind. You add the wind vector. You're also going to get more water wind because the bands themselves are coming up over the same place. On the other side, you have a shorter amount of time, and you may have some dry air also coming in and wrapping around it. You probably don't have any like thermodynamics, any clinic enhancement down there. Whereas when you get the storms up in the northeast, you may be coming up on an existing front or something which would enhance the rain, and you get the topo enhancement as well with the unit of those. So
This doesn't do
all of those go together.
This doesn't do it justice, but clearly a strong easterly flow on the north side of the storm. And then if you switch to this, you can almost imagine what's going to look like. There's like just a blob. It's still a complete tropical. All the moisture is being pushed in, and all the convergence is occurring in the easterly flow. You can see the big moisture blob in the PW field. The wind's probably far more impressive in a single model.
We had in the 90s, I lived on the Mississippi coast. We would have a couple hurricanes go ashore maybe 50 miles to our east, and at my house we'd get less than a quarter of an inch. No. You know, and of course there's all these flood warnings and death and destruction, and there's nothing. But on the other side, they get a lot.
Yeah.
So it's kind of looking like that, but it's still a long.
Look at that. This is the best I can do for this. It's hard to see, but there's this 8 sigma easterly wind just north of the cyclone center. So you can imagine the convergence in the wind. When you look at a single model, you can really, and this model's at, what's it, 16 kilometers now, I guess. You can really see. I got the mouse right over it. I apologize. It's a completely circular storm in the model's atmosphere. And I bet if we go into the precipitable water in this model, it's a blob of high precipitation. And then those winds as it hit the coast and it enhanced convergence. So that probably is skewing the rainfall. With Sandy, the easterly winds came all the way to Ohio.
Yeah, so this track right here should be really interesting because if the National Weather Service assumes the worst case scenario and puts out warnings for tremendous amounts of rain for Florida, and then it does take a track right along the coast, and all that heavy rain is shifted just to the east, and there's that tremendous gradient, the public could perceive that as a huge bust. So. Yeah,
and again, the principal water anomalies are about 5 sigma, and they're just off the coast. My experience, I worked at NMC, and the people who have done this at the WPC, who work with the Hurricane Center, they're well aware of the shear. They're well aware of the shear profiles and where the rainfall is going to fall. So. But our models simulate that really well nowadays too. It's going to be interesting, and maybe a great case study with the HURC. Anybody else?
All right, well, any other questions? I thank you guys for joining us this week. Thank you, Rich. We hope to see you all next week.
That's right.
You're going to get up?
I'm taking my chair.